Hi, this is Marty with Skincare Science. Welcome back to another video. In this video, I'm going to talk about polyhydroxy acid. I was asked what I thought of it a few weeks ago, maybe it was a month ago. Anyway, I apologize, I was supposed to do the video a while ago, so here it is. Basically, I don't do anything with polyhydroxy acid for very good reason. If you've seen any of my videos on sensitive skin or chemical peels with regards to Gesner, trichloroacetic acid, alpha hydroxy acid, or salicylic acid, I just don't think that these are needed, point blank. I took Allure magazine had an article. I did a simple Google search. And the reason I did that is I just wanted to know real fresh. I mean, I did it 10 minutes ago, printed it out. I just wanted to know real fresh, what's coming up, on the links. What is the majority of individuals reading? So I'm going to go ahead and discuss some of the things in here. And I think many of them pretty much you've already heard or seen. Again, I have my glasses, so it's hard for me to see, far away. So, all right. So basically, this article is, little statement here, says polyhydroxy acid, PHAs, has a larger molecular structure when compared to AHA, which means it's gentler on the skin, making it safer for those with sensitive skin. Well, I don't understand that at all. And the reason why is because it's an acid. And even though it has a larger molecular structure to it, it's still an acid. So if salicylic acid is the go-to acid for acne treatment because of its smaller molecular size, which means that it is able to help exfoliate the transitional skin that is in the pores, correct? That's why it's the go-to and has been and probably will always be. So how does a larger molecular structure maintain a property for sensitive skin? So if make a comment, email me, because I don't understand that. Does that mean that it's not going to penetrate into the pore? Okay, fair enough. But that acid is still, the acid is still determined by its pH and its pK value. So continuing on with the article, let's just pause on the molecular structure for a second. Joshua Zeichner, Director of Cosmetic and Clinical Research in Dermatology at Mount Sinai Hospital in New York City, told Allure magazine, if you step on a thumbtack, even though it's little, it's going to hurt. Now let's think of a bed of nails or thumbtacks. You can actually step on those because the weight is distributed. Okay, I get the physics behind that. That's like the person who lays down on a bed of nails and is able to do that because each one is distributing the weight of the entire body laying on it. So, obviously we've seen that in magic shows or whatever, or circus, whatever. So we get that or on TV, whatever. Okay, so continuing on in non-science speak, Josh, Director of Cosmetic and Clinical, okay. So Mount Sinai Hospital. Okay, so Joshua Zeichner is not a doctor. He's the Director of Cosmetic and Clinical Research. Okay, so I know it. Okay, so Joshua Zeichner, being the Director of Cosmetic and Clinical Research, is the one who writes about the studies of the clinical research of new products of dermatology and says if there's 36 patients, 12, half are men, half are women, each applied this, the placebo this, and 20% got this result and all that. Okay, that's what this individual does. Fine, fair enough. There's a lot of experience there, but in non-science speak, Zeichner's analogy basically means that while AHAs penetrate deeper and faster into the skin, PHAs take their time with a less jarring effect, which is why pHs are better suited for those with sensitive skin. And it's also a humectant, which means the ingredient pulls moisture into the skin to help keep it hydrated as it's exfoliating. Okay. Okay, so draw the famous 3 lines, right? Okay, so epidermis, dermis, this is the stratum corneum. Okay, so we have the AHA molecular size. We have the, well, they only compared it to AHA, so we'll do AHA and PHA. PHA, okay, and there it is. All right, I'm not going to debate the humectant attribute that the article talks about. And the reason why is because I don't know, because the article doesn't talk about what the pH is of this or the percentage. It's just basically saying this molecule. Well, pH is critical. So without knowing the pH, I can't speak to the humectant side, because if you have an AHA product and the pH is above 3.8, that AHA is no longer an acid and is now on the non-acid alkaline side, and it becomes a normal moisturizer, like water. You know, like it's an ingredient that no longer is exfoliating. So therefore, it's doing the opposite, which is hydrating. Fair enough? Okay. So if you look at the size of this polyhydroxy molecule that I've basically, made up. I mean, I do not know the difference in size. Yeah. Okay, I'm sorry. Okay, without knowing the pH within the ingredient, this discussion is pointless, because the pH and the pK value of the polyhydroxy acid, along with the percentage, determines what it's going to do to the skin, regardless of the molecular size. If the pH is made lower, that pH is going to irritate the skin, which has nothing to do basically with the acid in and of itself, as people are talking about this. AHA and BHAs are tried and true. Salicylic acid, Gesner. I think that polyhydroxy acids are just another attempt by the skincare industry to bring something new out and sell more product. Proof. AHAs are coat time dependent. So, and BHA as well. So if you are truly worried about sensitive skin and the amount of time you would apply and remove very quickly, if polyhydroxy acids need to be neutralized and you leave them on the skin, how is that molecular size? See, I don't understand. Is it just sitting within the stratum corneum? Because it's time dependent. Basically, what I think that they're saying about this, if I expand on it and anticipate or assume what others would say based on the larger molecular size, it would be, it's sitting on the skin, it's time dependent, and without neutralizing it, it's going to stay on the upper parts of the stratum corneum. You see, then why would you use it then? Because yeah, why would you use it? You basically would want to stick with AHAs and dilute them. Yeah, no. Yeah, no. Okay, yeah, this is an attempt by the skincare industry to push more product on the consumer. That's all that this is. If in fact this is true with the PHA being a stronger molecular size, I'm sorry, a larger molecular size, AHAs and alpha and beta hydroxy acids are proven 30, 40 plus years, 50 years. I mean, it's like ridiculous, right? Okay, so there are so many different ways to apply AHAs and BHAs so that you can use them on sensitive skin. You can dilute them down. You can buffer them. And you can do that in treatment and at home with a little bit of education. I will not put these in my line. I will not do anything with them. Yeah, no. Okay, so that's it. Yeah, no. It's, yeah. Oh, dear. Oh, man. I wish I could lie. Okay, this is Marty with Skincare Science. And you know what? Okay. If you use AHAs and you use BHAs, okay, and you don't like them, I'm going to say you haven't been educated properly. But with that being said, if you use this and you are getting amazing skin, then I am so happy for you. You're not a customer of mine. You're a customer of someone else's. But I have to stay true to what I believe, who I am. I can't lie, and I can run circles with the right amount of education around polyhydroxy acids. So yeah, no, I'm not going to do this to my clients and bring in all this crazy stuff and just create so that my clients and, their inventory swells and clients get more confused, right? More confused. Yeah, no. Okay, I'm done. This is Marty with Skincare Science, and we'll see you in the next video.